Hi there, my name is Gabriel Reed, and this is my lab report on our first lab, the amount of excess charge on an ordinary object. So I broke down this lab into four different sections: our introduction, our physics breakdown, the experiments and our observations, along with any conclusions and remarks we might have. So first, what is the exact purpose of the lab? Well, we want to create and use charge tape in order to find out the amount of excess charge on one piece of charge tape. And by that, find the amount of excess charge in ordinary objects. We'll have to try and detail the forces interacting with the piece of tape we are observing to help find the results needed, such as the gravitational force and the electrical force, which we both found to be 1.967 times 10 to the negative third newtons. And we also found the magnitude of the charge on the tape to be 9.357 times 10 to the negative ninth coulombs. So, what actual physics concepts should we really focus on for this lab? Well, we need by first need to know Coulomb's law and Coulomb's constant. This law helps describe and quantify the electrical force between two objects, with the equation being Coulomb's constant, which is 9 times 10 to the ninth, multiplied by the two charges of our system, divided by the distance between the two charges. We also need to know our gravitational force, which is simply the mass of an object multiplied by the gravity of its setting. And for our experiment, it's being conducted on Earth, so that will be 9.8 meters per second squared. So, also, what kind of assumptions should we make before we do the lab? We have to assume that the charges of the tape are point charges and they're concentrated at the center of the piece of the tape. Our system is also the tape we're trying to, well, our system is mainly the tape we're focusing on floating, and all other parts of our system, including the books and the first piece of tape that we're holding, is considered to be the surrounding of the system. There is no air resistance in our system, and the books do not exert any force onto the piece of tape in the system. That is our final assumption being made. So, in our first experiment, we had to create a 20 centimeter long U tape and attach it to the end of a table. But in order to figure out if it was charged or not, we have to move our hand close to the piece of tape to see if it's attracted or repelled. And in our case, it is attracted. That means that the U tape is charged. In order to figure out if it's positively charged or negatively charged, I ran a plastic pen across my hair to get it negatively charged and moved it close to the U tape to see if it was attracted or repelled. And since the U tape was attracted, that means that the U tape is positively charged. In order to check this, I made another piece of U tape and brought it close to our original U tape. And since they both repelled, that means they were both positively charged. In the second and final experiment, we aim to find the amount of force exerted by U tape A onto U tape B, and that'll be considered our electrical force. And once we find that, we can solve for the charge of U tape B. So once I bring U tape A close to U tape B, when they start hovering, I measure the distance of those two pieces of tape to be 0.02 meters. And assuming that the electrical force and gravitational force are the same in our system, we're able to solve the charge for U tape B to be 9.357 times 10 to the negative ninth coulombs. When we check this into our glow script calculation, we can concur that the gravitational force and the electrical force appear to be correct within our system, and that the charge of U tape B to be 9.357 times 10 to the negative ninth coulombs. So, what if electrons had positive charge and protons had negative charge? Would this change the observations we make with our tapes and our other charge objects? It actually wouldn't affect our system in our experiments, since the two tapes would still have similar charges and repel each other. We know that, and the tape would still be attracted to the pen since they would still have opposite charges. Because if we just rub the plastic pen in my hair, it would get positively charged, and I bring that to the negatively charged U tape, they would still attract. But then we have to consider, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Well, when the tape comes in contact with my hands, I believe the tape will reduce its charge and try to become neutral, with excess electrons trying to escape the system being the tape in our hand in contact. If in contact with another object, I believe the charge of the tape will still try to become neutral as it would if it came in contact with our hand. Thank you for listening to my presentation.